So now we're gonna go over how to improve a machine learning model. And we're gonna go over two ways on how to do this with Randomizedsearchcv and GridSearchCV. I will explain what each of these mean when I get to them. So I already imported all the necessary libraries, and I will import the rest when we get to the functions that we need from them. So now let me import the data. Then I'm going to put the features into X and the targets into Y. I'm going to set up a random seed for reproducibility. Then I'm going to split the data into training and test subsets. Now let's run that cell, and we have no mistakes. So next I'm going to create a function that evaluates and tells us the accuracy score, precision score, recall, and the F1 score. So I already imported these, so let me create the function. I'll call this yTrue and yPreds. And I'm just going to speed through this because if you've been on my channel, you already know how to make a function. So I'm going to set accuracy to the accuracy score. And then I'm going to put yTrue and the y predictions. Then I'm going to set a precision variable to the precision score. And it will also take yTrue and y predictions. Then the recall. Then I'm going to set the metrics dictionary. So whatever score we get for the accuracy, I'm going to round it by 2. There should be a comma here. And then precision. I'm going to round our precision variable we just made, rounded by 2. Then the recall. I'm going to round recall by 2. And then the F1. Then this is what we want to print. Gonna round it by 100. And then we want a percent after that. Let me just copy this. Next is the precision. And here we're going to put our precision variable. And then the recall. And we want our recall variable. Then the F1 score. This is going to be F1. Let me remove the 100%. And then I want to return matrix dictionary. Let me run that to see if everything's okay, and it seems that we didn't make any mistakes. So next, let's create a baseline random forest classifier model. So let's set the random seed. Let's make and fit the baseline model. Let's see, equals random forest classifier. And then let's fit the training data. Let's put our predictions in a variable. Create a variable called baseline matrix. Let's call in our function, and then let's put our y tests and y predictions. And let's run that. And you see here we got our accuracy score, precision score, recall score, and F1 score for our baseline random forest classifier. Next, let's try to better these scores with Randomizedsearchcv. And the Randomizedsearchcv is a tool in machine learning that helps find the best parameters for your model. So instead of trying every possible combination of settings, which will take a lot of time, Randomizedsearchcv randomly selects a few combinations and tests them to see which one works the best. So let me import Randomizedsearchcv. And then let's make a grid of parameters that we can adjust and estimators, and it's going to be in the form of a dictionary, so this should be in between quotes. And I'll explain what each of these parameters mean once I'm done writing them. So 10, 20, 40, 50, then 100. Next, we're going to use the max depth. And the option is none, 10, 20, and 30. So the main samples split. So now let's set up the Randomizedsearchcv. So rs equals clf randomized search, and let's set the estimators to our random forest classifier that we created here, the clf, and the param distribution. I'm gonna set that to the grid we created. Then the n iteration, we're gonna set that to 50, and this means that we're gonna randomly try 50 variations of these parameters. And we set the CV to 5, so we want 5 fold cross validations. And I set the verbals to 2, and the random state to 42. Now let's fit our randomized search version of our random forest classifier. So rs_clf.fit, and we put our training data. And let's run that. Oh, we need to delete this. Let's run that. And so let's see our mistake. Estimators, it's supposed to be with no S. Let's run that. Got another mistake, param distribution. I think it should be param distributions with an S. And let's run that. Okay, we have another mistake. Valid parameter, bootstrap. Okay, I spelled bootstrap wrong. Let's run that. Okay, and now it's doing its thing. It will take a little while because it's randomly trying each of these. So I said I was going to explain each of these. So the N estimators is the number of trees in the forest, and having more trees usually helps the model make better predictions, but it takes more time to run. The max depth is the deepest a tree is allowed to grow. Keeping trees from getting too deep helps avoid the model from memorizing the data or overfitting. The max features is how many columns the model looks at to split the data. Using fewer features make the trees more different from each other and can improve the results. The min sample split, this is the smallest number of data points needed to split a group. Larger numbers stop the trees from splitting too much and help prevent overfitting. And the bootstrap is whether the trees are built using repeated samples. Using this adds randomness, making the model more flexible. So I got these from just doing a quick Google search, and I arrived at the sklearn website and just typed in the grid parameters for Randomizedsearchcv and for a random forest classifier model, and it gave me these and these values. So let's see if our random forest, if it's done. And it's done. So now let's look at the best parameters. So rs.clf.best_params, and we have to add an underscore after this. Let's run that. And you see it got the best parameters for our model. So it went through all of these randomly and it shows the best ones. So N estimators, it shows 100. Min sample split, it took 4. Max depth, none, and so on. So now let's evaluate the randomized search model. So I'm going to create a variable, randomized search, ypreds equals our randomized search classifier dot predict. I want to predict the X test. Then I'm going to create a variable called rs metrics and set that to our let's call our evaluate function. Then I'm going to put y test and then our rs ypreds. And let's run that. And you see we improved our model. So here the accuracy is 86, precision 85, recall 91, the F1 score is 88. And if we scroll up to our baseline model, we improved. We improved the accuracy by 3, the precision by 1, the recall by 6, and the F1, let me see what the F1 was. We improved that by 4%. So the randomized search CV, it improved our model results. So now let's do this using the GridSearchCV. So I'm going to import GridSearchCV. So from sklearn.model_selection, I'm going to import, it's with a capital G, GridSearchCV. So I'm going to set up another grid. Let's call this one grid 2. So I want the N estimators should be in between quotes. 100, 200, and 500. Set the max depth to none. I set the max features. So the reason why I'm putting less values is because grid search explores all different combinations, and that would take long if we put this type of grid. It will take longer. So that's why I'm putting less parameters. So GridSearchCV help us find the best settings for machine learning models by exploring all combinations of parameters values defined in the grid. So since it's exploring all combinations, it will take a little longer. So now let's set up the grid. So gs underscore clf equals GridSearchCV. Set the estimator to the CLF variable because we're trying to improve the same baseline random forest classifier here. So that's CLF, the param grid. Gonna set that equals to grid2, which we just created. The crossfolds, gonna set it to 5, and the verbose equals 2. So now let's fit our grid search the grid search version of our CLF. Put in our training data. And let's run that. We have a mistake. Found input variables of inconsistent numbers. And here it should be min samples. Let's see if, okay, let's run that. Okay, it's supposed to be Y train because I'm training the training data, not the X train and then the Y test. Let's run that. And then our grid search CSV is exploring all combinations to find the best one. So it will take a little while. And now it's finally done. So now let's find the best parameters. So let's go to our grid search cv.best params. Let's run that. And you see we got the best parameters. Let's now evaluate our GridSearchCV model. So let me set a variable called gs underscore y predictions equals gs underscore clf dot predict. We want to predict the x test. Now let's set a variable called gs metrics. I'm putting this in variable because I want to later on create a bar graph to compare the evaluations. So let's call our evaluate function that we created, and it takes the y test and our GSY predictions. Let's run that. It did better than our baseline model, but let's see how it did with against the random forest model. So the random search CV. So let's see here, 86, 85, 91, 88, 85, 85. Okay, so our random search CV did the best. So let me compare metrics. I'm gonna create a data frame and then a bar graph. So let me create a variable called compare pd.dataframe. Baseline to baseline metrics. That's why I put all the metrics in a variable so I can do this, what I'm doing now. Call this one the random search rs metrics. So on the grid search, the gs metrics, and this is supposed to be curly braces, not block braces. This is a dictionary. Next, I'm going to create a bar plot. Set the axis to compare dot plot. And set the fig size to 8x6. And let me add a legend. Let's give it a title equals models. And I'm gonna put it in the middle. So the location equals center. Set the columns to 3. Let's run that. And here we created a bar graph comparing the accuracy, precision, recall, and F1 score of our baseline model, random search model, and grid search. So this is how you improve a model using random search CV and grid search CV. In the next lesson, the next and the final lesson actually, we're gonna go over saving and loading trained machine learning models.